Our new objective is I can divide using the standard algorithm. We've now had quite a few weeks where we focus on what division is, and we've learned partial quotients. But today we're going to move into the standard algorithm, which, once you have an understanding of place value, is probably the quickest and most efficient way to solve a division problem. Just a real quick review of vocabulary. Some vocab that we need to know for division. First, we've got dividend, divisor, quotient, and quotient. If I have a division problem that's written like this, 16 divided by 8 equals 2. The 16 is my dividend. The 8 is my divisor. The 2 is my quotient, or the answer to a division problem. If I write this in the 4 different symbols or methods of division, this could also be written as 16 divided by 8 equals 2. 16 divided by 8 equals 2. And 16 over 8 equals 2. And all of these, my 16 dividend, that is a number that I have that I'm splitting into equal sized groups. My 8 is a divisor. That's the number that's doing the dividing. It could either represent how many I'm putting into a group or how many groups I'm splitting my dividend into. And my 2 is my quotient, or the answer to a division problem. We also need to understand inverse operations that would tell me that because 2 multiplied by 9 gives me 18, the inverse operation of multiplication is division, so that tells me I can take my quotient, my product, of 18 and divide it by either of my factors, and my quotient will be the other factor. That is what inverse operations can help me do. The steps for the standard algorithm are really quite simple, similar to partial quotients, but you just have some shortcuts. Your first step is to set up your problem with the long division symbol. So we will have 7,434 divided by 5. My next step is to make my toolbox just so that I have some math facts ready and on my brain. All of them are going to be 5 times something because 5 is my divisor. So I'll say 5 times 1, 5. 2, 10. And there's my completed toolbox. Now, this time, rather than extend the long division symbol down, I'm just going to remember place value. The key to the standard algorithm is to keep my place values lined up. My first step, just like with partial quotients, is to move from left to right of my dividend and digit by digit ask myself how many times my divisor can go into that digit without going over. So I'm going to start right here with the first digit in my dividend, which is a 7. So I ask myself, how many times can 5 go into 7 without going over? If I look over here at my toolbox, I can see that the closest I can get to 7 without going over is this 5, which is times 1. So I write up top, I'll say I can do 5 times 1, which gives me 5. Notice how I kept those place values lined up. In order for my answer to remain true the whole time, I have to keep my place values lined up. It would be incorrect if I were to put the 1 here, because I'm not putting that 5 into the 4, I'm putting it into the 7 of the 7,000. So like I said, you have to make sure your place values remain lined up. Whoops, that's a little bit big. Then I subtract, just as I did with partial quotients, and I'm now left with a 2 here. I'll know that I picked the correct factor up here if when I subtract, my new partial dividend, this piece of it, is smaller than my divisor. Then, in order to continue down, I look to my next number of my dividend and I bring it down to join my difference that I just found. And now I have 24. And I look at this piece of the number and I say, okay, how many times can 5 go into 24 evenly without going over? I look over here at my math facts again and I look for something that's close to 24 without going over. 20 is close. Let's make sure I can't go one higher. 25 would be too much. So I know the math fact I want to use is 5 times 4 equals 20. Now again, what I have to do is I say 5 times 4 will give me 20. What was important here was notice that I lined up the factor that I picked with the last digit of the number that I was considering, which right here is this 4 in the 24. And I made sure to line up my 20 with my 24. Then I subtract again to find the difference. And I'm left with 4, which again I know can be correct because 4 is less than my 5. And then I bring down the next digit from my dividend. And I now have 43. And I repeat the same process. 5 multiplied by what is going to get me the closest to 43 without going over? Well, if I look over here, the math fact I want to use is multiplied by 8 because times 9 is too big. Making sure it stays lined up with that last digit I'm considering for now. I'm going to say 5 multiplied by 8 gives me 40. If I subtract, I'm left with 3. And then I bring down my next number. And I now have 34. Again, I ask myself which math fact is going to get me the closest to 34 without going over. I come over here, I look at all of these. Times 6 gives me 30. Times 7 is 35. That's too big, so I definitely want to use 6. Making sure it's still lined up, I put that 6 right on top. So I can subtract 34, subtract 30 is going to give me 4. Now, for now, I'm done with my dividend. There's not any more digits to bring down, and so for as far as we're going now, I say, okay, 4 is left. I check and make sure is that 4 smaller than my divisor? It is. So that becomes my remainder, which I'm writing as a fraction, as 4 over my divisor fifths. My final quotient ends up being 1,486. Now, the reason that I had to keep my place values lined up the whole time was, if you'll notice, my thousands are above my thousands, my hundreds above my hundreds, my tens, my ones. I have to keep my place value lined up or my answer would be incorrect. If you look off to the right, I've solved this using partial quotients now, and you can see the similarities. The only difference is the standard algorithm creates a shortcut with the place values so that I don't have to look at every single one to see how many zeros to use and how many place values to use. Rather, I've got this shortcut that just puts the digits in the correct place value automatically so long as I keep them lined up. The last thing that I want to do with a division problem is check my answer once I'm done to make sure that I did it correctly. Because of inverse operations, I know that if I take my quotient without the remainder and I multiply it by my divisor, and then at the end I add back in my remainder, I should end up with my dividend. So if I check that, 5 times 6 gives me 30. 5 times 8 is 40, plus 3 is 43. 5 times 4 is 20, plus 4 is 24. 5 times 1 is 5, plus 2 is 7. So I have 7,450. And I need to add back in my remainder, or what was left over. So if I add back in that 4, I'm left with 7,434, which is the same as my dividend, which tells me that I did it correct. If you got a different answer here, that would be your point to say, I did something wrong, I need to go back and I need to fix it. This is the end of the standard algorithm lesson. So just make sure the keys are that you know your math facts, that you keep your digits lined up, and that you check your answer when you're done.